Hi, welcome to our last probability distributions video. This is all about triangular distribution. Now, some distributions take on a triangular distribution shape. It's got to be continuous data that's measured, and it takes the shape of a triangle with the lowest value, a highest value, and a mode or peak. Here are the parameters for a triangular distribution. A is our lowest value, B is our highest value, H is the height of the triangle, and there's a little formula given on the formula sheet to work out H, 2 divided by B minus A, and the area of a triangle. We know the area of a triangle is half times base times height, which is going to be half times B minus A times H, and it always adds up to 1. We talked about this in the last video, that whether it's rectangular, triangular, normal distribution, even a probability distribution table, the area or probabilities always add up to 1. All right, here's our example for the video. A lawyer has told his client that they will ring them sometime on Tuesday between 2 p.m. and 2:20 p.m., but most likely to be around 2:15 p.m. So it's going to be a triangular distribution. The 0 represents 2 p.m., 20 is 20 minutes later, the 15 is 2:15, and that's why it's triangular, because we have this peak at 2:15. That's the greatest probability of them calling then, the peak. All right, A is our lowest value, which is 0. B is our 20, our highest. The height of the triangle, let's work that out with this little formula. We're going to go 2 divided by B minus A, so 20 minus 0, which simplifies to 1/10, which is 0.1. So the height of the triangle is 0.1. And let's do a quick check to see if the area is 1. So area of a triangle is half times base times height, so half times 20 minus 0 times 0.1. And that does indeed give us an area of 1. All right, let's get into our first part of the problem. What is the probability the lawyer will ring before 2:10? Well, I put down 10 on my diagram and coloured in everything least for this purple triangle. And we're going to work out the area of this purple triangle because the area is the same as the probability. Before we do that, we need to get the height of the triangle. Now, if we're on the left-hand side of the peak, here's the formula to work out the height of the triangle, and it's on your formula sheet. Now, C happens to be the x value at the peak. Now, it's just a game of substitution, so it's 2 times x minus a on the top divided by b minus a times c minus a on the bottom. So whenever you see an x, you put 10. Whenever you see an a, you put 0. Whenever you see a b, you put 20. Whenever you see a c, you put 15. You substitute that into your calculator, and you should get a height of 0.06 recurring. So we know the height of the triangle is 0.06 recurring. Now we can go on and work out the area of the purple triangle, which is half times base times height, so half times 10 minus 0 times a height of 0.06 recurring, which gives us an area of 0.3333, which is the same as the probability we're trying to figure out. The probability that they'll ring before 2:10 p.m. is 0.3333 or 33.33%. All right, part B, what's the probability the lawyer will ring after 2:18? Well, again, I've put 18 on my diagram and I've coloured everything in greater than 18. That little tiny purple triangle, we're going to work out the area of it to get the probability. But before that, we need the height. Now, if we're on the right-hand side of the peak, the formula to work out the height of the triangle changes. It's on your formula sheet, and again, C is the x value at the peak. Now, it's 2 times b minus x on the top divided by b minus a times b minus c on the bottom. So again, it's a substitution game. Whenever you see x, it's 18. Whenever you see b, it's 20. Whenever you see a, it's 0. And whenever you see c, it's 15. So once again, we substitute into our calculator and we get a height of 0.04. So the purple triangle's got a height of 0.04. So let's go on and work out the area of the purple triangle. Half times base times height. So it's half times 20 minus 18 times a height of 0.04. The area is 0.04. So the probability that they'll ring after 2:18 is 0.04 or 4%. Right, well, that's us for this series of videos. So thank you so much for tuning in.